This will be for the con assignment, mean expected value of a discrete random variable. So there's a relatively simple formula for expected value, E of x. It just equals the sum of x times P of x. Okay, this symbol here is the Greek letter sigma. It means sum of. X is each individual x value, and P of x is the probability of each individual x value. So you just multiply each x value times its probability and continue doing that and add all of those together. That will be your expected value. So you can read the write-up. It's not really necessary in this particular problem. Maybe all the problems you won't have to. Okay, we can clearly see that we have number of pike fish that were caught and the probability for each one, and they want us to find the expected value of the number of northern pike Elena catches. All right, so we're just going to do the sum of each of these probabilities. Okay, we're going to do the sum of x times P of x. All right, so we can probably just do our work right here. Okay, so the first one, well, you know what? I better write it out just in case. All right, we have 0 fish, that's our x, times the probability of catching 0 fish, which is 0.09. And then we have 1 fish, and the probability of catching only 1 fish is 0.42. And then 2 fish, and the probability of catching only 2 fish is 0.49. Okay, and you just do this on the calculator. The one with 0, you don't really have to enter in the calculator because that's just 0. All right, and I get 1.4 on the calculator. So based on these probabilities, the likely number of fish that she will catch on average is 1.4. So you just enter that in the box. You click inside the box and type 1.4. All right, again, the write-ups are probably not necessary in this case. I'll just read it for now. Jordan wants to play a basketball game. The game costs $5, and the player gets to take 2 long-distance shots. If they miss, they get nothing. If they make one, they get $5. If they make both, they get $10. He has a 40% chance of making the shot. All right. So these are the number of shots made and the probability. Okay, and this is the amount of money gained on each incident here, on each scenario. So if he doesn't make any shots, he loses $5 because that's what he paid. If he makes 1 shot, he just breaks even. He gets his $5 back. If he makes 2 shots, he gets his $5 back plus an additional $5. And they're not looking for the amount of money made. They're just looking for the mean of x, the number of shots made. Okay, this symbol here, it's Greek letter mu. It usually is used to represent mean. So they're just looking for the mean of x, like it says in the problem. All right, not how much money. All right, so again, same formula. It's just going to be the sum of x times P of x. All right, so for 0 shots, that's going to be the first x. The probability is 0.36. For 1 shot, the probability is 0.48. And for 2 shots, the probability is 0.16. Okay, we don't need to enter the 0 in the calculator. It's just 0. The rest I'm going to do on the calculator. All right, on the calculator, I get 0.8. That's the average number of shots he'll make. So you can write 0.8 or just type 0.8 inside the box. So notice they gave us some unnecessary information. The money gained wasn't really a factor of this problem. All right. They just asked us the average for the number of shots, or the mean for the number of shots. All right, so I think these are basically the same. All right, we have number of children and the probability for each. On average, how many children would such a couple have? All right, so same thing. It's just going to be the sum of x times p of x for each one. All right, so these are the x values here. We have 1 times a half. These are the probabilities for each one. They put it in the form of a fraction this time. And for the 2, the probability is 1/4. And for the 3, the probability is 1/4. All right. I'm going to keep all these in terms of fourths because I want a common denominator. All right. 1 times 1/2 is 1/2. But in terms of fourths, 1/2 is the same as 2/4. Okay. And over here we have 2 times 1/4. Well, 2 times 1 is just 2, and the denominator is a 4. And then here 3 times a 4th. 3 times 1 in the numerator, and the denominator is just a 4. All right. So common denominator, 2 plus 2 is 4, plus 3 is 7. And the denominator is a 4. That's it. So it's just 7/4. Click inside the box. They'll take the answer like that as far as I know. 7/4. Okay, so here we go. Same problem, same write-up as problem number 2. And same table it looks like, but this time they want the expected value of the amount of money that he makes. All right. So let's see. So in this case, instead of the x's, we're going to use the m's. All right, so in this case, instead of the sum of the x's, we're going to say it's the sum of the m's times the probability p of m. All right, it's really the same thing. All right, so we don't have to worry about number of shots made. The probability that he loses $5 is 0.36. All right, notice that 5 is negative. That represents a loss of money. And then the chance that he makes $0 is 0.48. And the chance that he makes $5 is 0.16. All right, so just use the calculator. The 1 times 0 is obviously 0. So we'll calculate this. All right, on the calculator, I just get -1. So in other words, he is likely to lose money on this. So the average amount of money made, click inside the box, it's just -1.